Utilization and implied utilization. Utilization and implied utilization are interesting values that can be calculated when we analyze processes, and that are interesting measures to observe both for the whole process as well as for individual resources within the process. Utilization is basically a flow rate divided by capacity, or you could say how much is produced on a process or on a resource divided by how much capacity is available in the process or in the resource. So you see, we can divide it for the process, define it for the process when we divide flow rate over capacity, or for the resource, we need to divide the same flow rate by capacity of this resource. And the implied utilization is capacity that is required by demand divided by available capacity. So notice, implied utilization has the same denominator, available capacity, but the numerator is actually the demand, right? So I will use here IU as to indicate implied utilization. And for the process, again, it will be calculated by dividing demand over capacity of the process. For a resource, division will be by capacity of the resource. The interesting thing is that the utilization will never be more than 1. The reason for this is that capacity is maximum possible flow rate. So flow rate can never be higher than capacity. At best, they can be equal, in which case utilization is 1. But if utilization is less than 1, we underutilize the process or a resource. Implied utilization, on the other hand, can be more than 1. Why? Because demand can be higher than the capacity. And if it is higher than 1, it actually tells us how much more capacity we require in order to satisfy the demand, right? Actually, implied utilization of the bottleneck will be the highest. Also, implied regular utilization of the bottleneck will be the highest among all resources. So let's try to do some calculations of utilization and implied utilization. So suppose Circuit plant, as we calculated, has a capacity of 100 tons per hour. Now assume that this is a continuous operation, so it operates 24 hours per day and 360 days per year. What is the capacity per year? Now, we're not actually calculating a new measure, we're just expressing it in different units. It was tons per hour, we want tons per year. So what will it be? It will be 100 tons per hour multiplied by 24 hours per day, right? To convert hours, let's make this per day, and then multiply by 360 days per year, right? So this is just a conversion. If you do the calculations, you'll find out it is actually 876,000 tons per year, right? The second question, Circuit produced 657,000 tons of iron last year. What was the process utilization? Well, if it produced this much, this is actually flow rate. Notice that we have here tons of iron, unit of flow, per year, which is unit of time. So this is a flow rate. Flow rate utilization is a flow rate over capacity, right? So it's 657,000 tons per year divided by 800, right? Let's write here also per year, if you like. Right, so that's 0.75, or if you like, 75%. Right, maybe I'll change this. Right, so the utilization was 75%, which means we did not utilize the capacity to the maximum. We only utilized 75% of this capacity. Now, if demand in another year was 1,095,000 tons, right, which actually ends up being 125 tons per hour, what would be the process utilization and implied utilization? So if we had this demand, what would be the reasonable thing to do? Well, the reasonable thing to do would be try to satisfy this demand, assuming, of course, that sales, that selling the product is profitable, right? So we would actually be producing at maximum capacity. So in that case, utilization, which is flow rate over capacity, right, would make sense to process have flow rate equal to capacity. So the utilization would be 1 or 100%, right? Now, if the what is the implied utilization, however? Well, implied utilization, if you recall, is demand over capacity, and demand here is 1,095,000 tons per year, right? And we have to divide this by capacity 876 tons per year, which is 1.25 or 125%. So what this tells us is in utilization would be 100%. We would be working at maximum possible capacity, right? Maximum flow rate, actually, flow rate equal to capacity. But implied utilization tells us if we had a way to increase the capacity by 25%, we could then satisfy the whole demand in that year. We can look at utilizations and implied utilization through a bar chart, which indicates, in this case, utilization of every resource. So here you have the 7 resources, and the last bar is actually for the whole process utilization. And you will see that in our first example, when utilization was calculated to be 75%, right? The whole process has 75% utilization, and the bottleneck has 75% utilization. This is obviously always the case because the capacity of the bottleneck is equal to the capacity of the whole process, and that means they should have, if they have the same capacity, they should have the same utilization. So we could say that this space here between right 75% and 100% is a kind of mismatch between demand and supply of this process, right? And we can also talk about a certain mismatch between the additional mismatch for some of those resources, well, actually all other resources than the bottleneck, because they have higher capacities, some of them much higher than others, and so they actually have an even lower utilization, and this we could call imbalance, right, of this resource relative to the bottleneck. I want to add one more comment about utilization and implied utilization. It is often tempting for operations managers to try and maximize utilization. I want to warn you that maximizing utilization should not be your goal. Utilization is just an indicator that shows you that if something is underutilized, something has low utilization, there might be opportunities for improvement. But maximizing utilization might lead to just production for the sake of doing something rather than doing something useful or profitable, right? So if you maximize utilization of a worker, you might actually ask this worker to produce continuously products or parts that you will actually never use. That's actually creating more loss than profit, right? If you build up a lot of inventory and that actually has a high holding cost and maybe inventory that you will never be able to use, that's a bad decision. So I warn you, do not maximize utilization, just observe utilization and learn from it. Don't use it as an objective of process optimization.